This time we're supposed to find the output error voltage with matching resistor. Okay, so the resistor R5 is connected to the base of transistor Q2. Please notice that we have resistor R4 connected to the base of transistor Q1, and resistor R5 is connected to the base of transistor Q2 in order to reduce the output error voltage. So in order to find the output error voltage, again I'm supposed to find the input error voltages. Okay, so my V1 error is the input error voltage due to the input bias current. Okay, so the formula for it is RB1 minus RB2 times input bias current. Okay, so V1 error is equal RB1, which is in this case 10 kilo ohms, minus RB2, the resistor which is connected to the base of transistor Q2, 10 kilo ohms, times the input bias current. Input bias current is 620 nanoamps. 620 nanoamps. So V1 error is equal, okay, 10 kilo ohms minus 10 kilo ohms is 0, and I have 620 nanoamps. 0 times 620 nanoamps is equal 0 volts. Okay, so please notice that my input error voltage due to the input bias current is equal 0. So this is a very good sign. Next we're supposed to find V2 error. Okay, this is the input error voltage due to the input offset current. So the formula for it is RB1 plus RB2 times half of the input offset current. Okay, divide by 2. So I have V2 error is equal, RB1 is 10 kilo ohms plus RB2 10 kilo ohms, and I have input offset current is 120 nanoamps, and everything divided by 2. Okay, so I have V2 error is equal 20 kilo times 120 nano divided by 2 is 60 nanoamps. Everything is equal 1.2 millivolts. Okay, next we're supposed to find V3 error. So V3 error is the input error voltage, okay, due to the input offset. So we can say that V3 error is equal input offset voltage. Okay, and this is given. This is equal 1 millivolt. So I have 1 millivolt. Okay, so I found the 3 input error voltages. Next, I'm supposed to find the output error voltage. So V out error is equal the gain, voltage gain, times the sum of my 3 input error voltages. So I have V1 error plus V2 error plus V3 error. Okay, next we're supposed to plug in the values. So I have AV equals 320 times V1 error we found is equal 0 volts plus V2 error we found is equal 1.2 millivolts plus V3 error 1 millivolt. This is equal. Now we can use the calculator. We have 320 times, open parenthesis, 1.2 exponent 3 negative plus 1 exponent 3 negative, close parenthesis. This is equal 704 millivolts. Okay, so my error voltage is equal 704 millivolts. If we are going to compare this result with the result which we got in the previous problem, you will see how much error voltage has been reduced by adding simple resistor R5, okay, to the inverting input. Okay, so now we can say that this amplifier has much better performance than the previous one. So using the matching resistors is the way to reduce the output error voltage. Now I can say that the problem is solved.